Hello and welcome to the second video of the FP1 chapter Matrices. Starter question on the screen. Here we go. Explain why a 2x3 matrix cannot be added to a 3x2 matrix. This is because of the elements involved. We've got one here, 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 here for a 2x3, and then a 3x2, whatever these numbers are. And then as we go to add this one and this one, that's fine. This one plus this one, that's fine. This one, oh no, there's no element there. No element is different to the element 0. So we can't add these because they're not the same size. However, as we'll see in this video, we could multiply these two matrices. That's what we're going to look at here. Multiplying matrices and understanding when it is and is not possible. Matrix multiplication is very different to the operations so far. It's not obvious, and it is not always possible to do. It depends on the sizes of the matrices involved. Here we've got a 2x2 matrix and a 2x3 matrix, and these can be multiplied, and the reason for that is that the number of columns in this matrix matches the number of rows in this matrix. That's this number and this number are the same. Put them in green here. This shows you that the two matrices can be multiplied. The other two numbers, this number, the number of rows in the first one, and the number of columns in the second one, that tells you something as well. That tells you how big your answer matrix will be. So here, this number and this number give you the size of your answer matrix. And the other two are indicating whether or not you can do the multiplication at all. Now the reason for this all comes down to how the process is done. And it's quite a strange process. So I'll talk it through and I'll put every step on the screen. What you're doing is you need to take the first row of the first matrix and the first column of the second matrix, and we're going to multiply A times E, and we're going to multiply B times H, and then we're going to add those two things together. So it's A times E plus B times H. You go along this row and down this column. And that will give you the first row, first column element in the answer matrix. Then you repeat with the first row, second column. AF plus BI, and that will give you the first row, second column element in the answer matrix. And then you continue. First row, third column. For the first row, third column answer, A times G plus B times J. And you can see here that this element times one of these and this element times one of these gives you a reason why we need a certain number of columns here. That gives us two elements going across a row, and a certain number of rows here, that gives us two elements going down a column, and they need to match, otherwise you end up running out of elements, and you won't be able to do it like we had in the starter question. So putting all of these on the screen here for the first row, you then go to the second row, first column. C times E plus D times H gives you second row, first column answer there. C times F plus D times I gives you O. C times G plus D times J gives you P. So this is a full statement of all of the multiplications that you're doing for a 2x2 and a 2x3 multiplication here. The specific statements will change depending on the size of the matrices, but that general idea stays the same. You take the first row, first column, and the individual elements you multiply, and then you add the next two, and if there was a third one here and a third one here, you would multiply them and add them as well. And I think an example will help to make this clearer. So here we have a 3x2 matrix and a 2x2 matrix, slightly different, and we're going to find A times B. That means I need A first. So we've got 5, 2, 1 minus 3, 0 minus 1, and then B second. 3, 4 minus 2, 2. So I take my first row and my first column. I do 5 times 3, that's 15, plus 2 times minus 2, that's minus 4. 15 minus 4 is 11. And that goes in the first row, first column of my answer matrix. Now let me just see what size that will be. Here we've got a 3 by 2, and here a 2 by 2. The 2's here are the same. That's telling me I can do this, it will work. And then the 3 here and the 2 here are telling me I should end up with a 3 by 2 matrix as my answer. So it should be the same type of matrix as A. So continuing along, I'm going to have first row, second column. 5 times 4, 20, plus 2 times 2, 4, gives me 24. I finished my first row, so now I go into my second row, first column. 3 plus 6 gives me 9. Second row, second column. 4 minus 6 gives me minus 2. Now I'm on to the third row, first column element. So I do the third row and the first column. That's 0 plus 2 is 2. And then finally 0 minus 2 gives me a minus 2 here. And this is the answer matrix for this multiplication. So here are the formal notes for that. To be able to multiply two matrices, the number of columns in the first matrix must be equal to the number of rows in the second matrix. If they are not equal, the matrices simply cannot be multiplied. If AB can be calculated, like it could in the previous example, it does not necessarily mean that B times A can be calculated. And if we go back and have a quick look at that, we can see why. Because if we put B first, we would have a 2 by 2 matrix, and if we put A second, we would have a 3 by 2 matrix. And doing it this way round, these two numbers would not be equal, so we would not be able to do the multiplication. So the order of your matrix multiplication is very, very important. If it can be done, then the answer matrix will have a size determined by the number of rows of the first matrix and the number of columns in the second matrix. So this is what I was saying. These two numbers being the same tells you you can do the multiplication, and then these two numbers, whatever they are, will be the order of your answer matrix. Matrix multiplication is not commutative. Even if A, B, and B, A both exist, they generally will not be the same. That doesn't mean they can't be, but generally you'll get different answers doing these two things. And finally, matrix multiplication is associative, which just means so long as you keep the order the same, it doesn't matter if you do these two first or if you do these two first, you'll get the same answer. It doesn't matter where the brackets go, so long as the order of the matrices from left to right is the same. Okay, that's a lot of writing on this screen, but most of that we went through in the example, and we've got a few more examples as well. So here we go. We've got A, a 2 by 2, a B, a 2 by 1, and C, a 2 by 2 matrix. Find these multiplications here. So I'll go through these fairly quickly. We've got 3 minus 2, 4, 1 times B. And as I said, it's very important the order. So A is on the left here. So the A matrix must be on the left, B on the right, B on the right. So we better check we can actually do this. We've got a 2 by 2 and a 2 by 1, so yes, this will work. And I wouldn't normally stop and think like that. What I would normally just think to myself is, can I actually do this, or am I going to run out of elements somewhere? And I can see straight away this times this plus this times this. That's going to work. So we've got 3 plus 4 is a 7. And that's it. First row, first column. There is no second column here. So I've got first row, first column, and then I go into my second row. 4 minus 2 is 2. And there we have the answer for part A. Part B, A times C. 3 minus 2, 4, 1. 5, 2, minus 2, 3. A 2 by 2 times a 2 by 2 is fine. That will give us a 2 by 2 answer. 15 plus 4 6 minus 6 20 minus 2 and finally 8 plus 3. Here is the answer for part B. Part C is showing us that this is going to be a different answer. If we put C first, 5, 2 minus 2, 3. 3 minus 2, 4, 1. Now we get 15 plus 8, and you can see that that is already different. Minus 10 plus 2. Second row first column, minus 6 plus 12. And second row second column is 4 plus 3. Finally, we have part D. A times C times B. We get 3 minus 2, 4, 1. C must be in the middle. 5, 2 minus 2, 3. And B must be on the end. Now that we've got them in the correct order, I could either do this times this first, and then do this times the result, keeping this on the left, or this times this first, and then do the result times this, keeping this on the right. And because I already have the result of A times C from part B, I'm going to do this. So quickly write that out. We've got 19, 0, 18, 11, and then B must still be on the right of that result. So now we've got 19 times 1 plus 0 is 19, and 18 times 1 minus 22, which is minus 4. And to convince yourself that A times C first, then times B, is the same as C times B multiplied by A, so long as A is kept on the left, you could do that yourself and see that you get the same result. Second and final example. If A is this and B is this, given that BA equals the zero matrix, 1 by 1 zero matrix, find AB in terms of A. So we're going to be using this information here first to find something useful to relate A and B, and then we can find the result in terms of A for the second part. So let me write out BA. This is what they're telling us. This times this is equal to the zero matrix. Now if I get rid of that 0 for a second and actually do this multiplication, we have B times minus 1 plus 2 times A. So we have minus B plus 2A, and that is a single element, and that single element must be a zero element, which tells us that B must equal 2A. Now we have that information, we can put that back in and find AB. So this was BA. Now AB is equal to a minus 1A times B, which we now know is 2A 2. And this will not give us a 1 by 1 matrix. This will do first row, first column, first row, second column, second row, first column, second row, second column. This is going to give us a 2 by 2 matrix. And in terms of A, that will be minus 2A, minus 2, 2A squared, and finally 2A. And this is the answer for AB in terms of A. That now should be enough for you to have a go at the questions in exercise 5b, and maybe I'll see you for the final video in this chapter.